All right, guys, so I'm going to start in on our final exam review. For this first video, I'm just going to do questions 1 through 9. So we're going to cover systems, which was Unit 5, if you need to go back to your notes and review what we learned about systems. I've gone ahead over here. These are the 3 methods that we learned to solve a system that you need to remember. The graphing method is when you just graph it, and remember, we're looking for the one point that the 2 lines have in common. That's their solution. So the graphing method is nice and easy because you can just graph the 2 lines and see where they cross. The only downfall to that, of course, is that both of your equations need to be in y equals mx plus b form. The substitution method is when one of your equations says x equals or y equals, so you can just substitute that expression in to the other equation. And then the elimination method is when all of your like terms are aligned and you want to eliminate either the x's or the y's to solve for the other variable. I'm going to try to do one of each of those with these questions just to kind of refresh your memory. Okay, so here we go. On all these problems, we're going to write the system and solve, because that's what the directions are telling us at the top of the page. So here we go. An ice rink charges an admission fee plus a rental fee for ice skates. Okay, so we have 2 different scenarios here for John and Juanita, and we're going to write an equation for each person. So John paid the admission fee for his 6 nephews, right? So 6 admission fees, right? And he rented 5 pairs of ice skates, right? And he was charged $32. And the most important part of this, like we talked about in class, is that $32 is a total amount of money that he spent. So we know that that is going to be, our equation is going to say equals 32, right? This is going to be in standard form. All right, so anytime you're given the total amount of money or whatever whatever items you're talking about, right, it's going to be a standard form. So that's going to be an AX plus BY equals C equation. All right, and they're telling you, it says let A represent the admission fee and R represent the rental fee for the skates. All right, so here we go. So John, he paid 6 admission fees, so 6 A's, plus he rented 5 pairs of skates, so he has 5 rentals, and that is a total of $32. All right, so there's John's equation, and then we're going to do the same thing for Juanita. Right, and Juanita paid 7 admission fees, right, and also 5 pairs of skates, right, but her total was $35.25. So also a standard form equation, so 7 admission fees plus 5 rentals, and that was $35.25. All right, so there's our system. Now we have to figure out a way to solve for how much the admission fee is and how much it costs to rent 1 pair of skates. So clearly we should be using elimination method, right? Elimination method, because all of our like terms are aligned, right? A's, R's, equal signs, constants, everything's aligned. So we want to get one of our variables to eliminate if we add vertically, right? It's also called the addition method, right? So if I was to add vertically, would any of my terms cancel? And no, right? But we're so close to canceling because our 5 R's, right? They're both 5s. So I know that if we just, I'm just going to do the top equation. So if I were to just multiply the top equation by -1, right? And you got to go all the way through and multiply everybody, right? If you can't just change one term. So that's going to give us -6A minus 5R equals -32. So I've rewritten that equation. It's still the same line, right? It's not, we haven't changed the linear equation by multiplying by -1, right? And so now I'm going to use the elimination method and I'm going to add vertically, right? So 7 A's minus 6 A's is going to give me 1A. The R's cancel out or eliminate themselves exactly as I wanted them to. And then I'm going to subtract the 35.25 and -32, so that's going to give us $3.25. Okay, And there you go. That's going to be our solution for A. Okay. All right. Then, so I'm just going to go over here. I'll just say A equals, and it is money. So the admission fee is $3.25. But now we still need to find that skate rental fee. So now I'm going to pick either equation. It doesn't matter which one. I'll just use the 7A one. So now that I know, so I'm going to pick 7. The admission fee is $3.25. So again, I'm just picking that equation because it's the one I haven't messed with the most. You can pick either equation. We'll all get the same answer. So I'm just going to substitute the A value in. And then I'm going to solve that equation, right? So I'm going to multiply $3.25 times 7, which is going to give me $22.75. And then I just have this quick little two-step algebra equation to solve, all right? So let's see, the first thing we're going to do is we're going to subtract that 22. I've run out of room. I should have done it on the other side. Here we go. I'm just going to move it over here. I'm going to do 35.25, and I'm going to subtract the 22.75 to the other side. So that's going to give me 5R equals $12.50, or just 12.5. And then I'm going to divide by 5, and that's going to give me 2.5. And that is the skate rental fee, right? So the skate rental is $2.50. And there we go. We just solved the system because we solved for both variables. And you can always check your answer by plugging it into the other equation if you want to. All right, we can multiply 6 times 325 plus 5 for the skate rental and see if we get $32, and we do. All right, let's go do number 2. Number 2 is one of the coin questions. We did quite a few of these. So notice they said, let N represent the number of nickels and D represent the number of dimes. Okay, so it says a jar containing only nickels and dimes has a total of 60 coins. Again, if you're given the total amount of money or total number of items, that's automatically going to be standard form, right? So nickels and dimes, 60 of them. So nickels plus dimes equals 60, right? Then we read our second equation. The value of all the dimes is $4.45. Okay, so that's a total amount of money. But remember, when you're talking about money, money can only equal money, right? So everything in our equation has to talk about the money value of nickels and dimes. So I know it doesn't say it in the problem, but you have to insert that nickels are worth 5 cents each, dimes are worth 10 cents each, and if we add up all that money, we get $4.45, right? Money plus money equals money, okay? All right, you can totally use elimination for this if you want to, like we did on the previous problem, because everything's aligned, which is nice. I'm going to use substitution method, though, just to kind of get some practice with that one in. None of my equations say N equals or D equals, but I can really quickly, I can just use this top equation and solve for N or D very easily by just subtracting the other variable to the other side. So I'm going to rewrite this equation as 60 minus D, right? I'm just subtracting the D to the other side. And now that I have an N equals equation, that means wherever I see an N, and then I'm going to go in the other equation, and I'm like, yay, there's one right there, right? So wherever I see another N, I can substitute 60 minus D in its place. Okay, so that's what I'm going to do on this problem. All right, I'm going to go over here to the right, though, because I don't want to run out of room like I did up top. So here we go. I'm going to completely rewrite that problem. I'll change color. So 0.05 times N, but I'm not going to write N. I'm going to write 60 minus D, and then plus 0.10 or 10 cents D equals 4.45. So I just rewrote that bottom equation and I substituted 60 minus d. And again, you don't have to do it this way. I'm just trying to give us a little variety. All right, so now we're just going to distribute that 0.05, right? So 0.05 times 60 is going to give us 3 minus 0.05d plus 0.10d, or just 0.1, equals 4.45. And then we're just solving this equation, right? It looks like we've got some like terms to combine here, right? So that's going to give us 3 and 5 cents, negative 5 cents plus 10 cents is going to give us positive 5 cents. Oops. And now we're down to just a basic two-step equation. So we're going to subtract the 3 to the other side, which is going to give us 0.05d equals $1.45, because we're subtracting the 3 from the 4.45. And now we're going to take the $1.45 and figure out how many nickels go into that. And we get 29. I meant dimes. I didn't mean nickels. Sorry. Well, technically, since we're dividing by 5 cents, but. So that helps us solve for the number of dimes. So there are 29 dimes. But now we still need to find the number of nickels, but luckily for us, right, we already have an equation that gives us the nickels, plus we already know there's 60, right? So we know we can just find the number of nickels by simply subtracting the 29 from the 60 to see what's left, and that gives us 31. Okay, sorry, I got lots of arrows going on there. So I'm just going to check my answer really quick. So I'm just going to multiply 31 times 5 cents and 29 times 10 cents and just make doubly sure I get $4.45. And I do. So I'm pretty good with our answer there. So we have 31 nickels and 29 dimes. There we go. All right, our last one, word problem here. So let's see. We've got one number is 12 less than 3 times another number. Okay, so remember, this is a write it as you read it problem. Anytime you start seeing words like is, less than, 3 times, some, right? These are all key words that are verbal phrases, right? So this is a write it as you read it. Right, and you know it's going to be a write it as you read it problem because of all those verbal translating words, right? All that vocab. So here we go. I always like to go find the word is or some form of the word is. It could be past tense like was or something like that. But the is always the equal sign, right? So here we go. So one number, okay, pick a variable. I'm just going to pick x. X is 12 less than, okay, remember, less than means I have to start with something in order to take 12 less than that. So that's going to be a minus 12 out to the side, right? I'm taking 12 less than something. 12 less than what? 3 times another number. So I need to pick another variable. I shall pick y. And there's our first equation for that sentence. Okay, so using just writing it as we read it. All right, then we need another equation. All right, so we're going to go over here. Their sum is, there's that is again, 188. And of course, you need to remember what sum means, right? Sum means to add. So when it says their sum, they're talking about the variables x plus y, and their sum is 188. Okay, so there's our system. All right, I know I just did... sorry, can't even think today. I know I just did substitution on the previous problem, but I'm clearly going to do substitution here again because we have an equation that says x equals, right? Anytime you have one of your variables by itself that technically has this algebraic expression, that means wherever I see an x, I can substitute in the 3y minus 12. So I'm going to take that 3y minus 12. Right, and I'm going to come around here and I'm going to substitute it in for this x. So I'm going to completely rewrite that bottom equation. X plus y equals 188, but again, instead of x, I'm going to write 3y minus 12, then plus y equals 188. And then we're just going to solve that algebra equation, right? We've got some like terms, right? On the same side, we've got a 3y plus a 1y, right? So that's going to give us 4y minus 12 equals 188. Right, and then we just need to solve that two-step algebra equation. So we clearly need to add the 12 to the other side, which is going to give us 200. And then we need to divide by 4, which is going to give us 50. So y equals 50. Now, of course, I still need to solve for x. Well, the easiest place to solve for x, well, actually either one of them would be easy in this case. So you could plug it into either one of these equations. I'm going to plug it back into that top equation because it's already technically solved for x. So x is 3y, but I just found out that y is 50. So I'm going to substitute that in again. There we go. And then I'm just going to do my math there, right? That's 3 times 50 is going to give us 150. We're going to subtract 12. So x is going to be 138. Right, and those are our two numbers, right? So 138 and 50. Voila. All right, moving right along. So we haven't done the graphing method yet, but that's what this one is for. So here we go. It says, given a graph, create and solve the system of equations. Now it says using substitution or elimination. I'm not going to do that here because it's perfectly set up for graphing to use Desmos. So I'm going to use graphing here just because I haven't practiced that yet. The one thing that's kind of crappy about this one is when you look at the graph, you'll notice that it's not passing through a perfect corner, like a perfect integer value. And so we're going to automatically, I'm pretty sure we're going to get some kind of gross numbers. So the first thing we need to do though is we need to figure out what the equations of these lines are, right? So I'm definitely going to write the equations of these lines in y equals mx plus b form. So I'm going to start with one line at a time. I'm going to start with my decreasing line here. And I'm going to find my y-intercept, which appears to be 6. And then it looks like I'm going down 2 over 1, down 2 over 1, down 2 over 1 to stay on that line, which would mean our equations, since we're going down 2 over 1, so that's a slope of -2, and our y-intercept appears to be positive 6. All right, so that's going to be the equation of that line. Then I'm going to go to my increasing line. So it looks like he has a y-intercept of -3. And let's see, it looks like I'm going up 1 over 2. I just want to make sure that stays consistent and I actually do have the right slope. And yeah, it looks like we're going up 1 over 2, up 1 over 2, up 1 over 2. So that means his slope is positive 1/2. And that y-intercept again was -3. So now that I have these in y equals mx plus b form, I'm going to go to Desmos and I'm going to type those two equations in. Okay, I'm going to write those down really quick just so I don't forget them when I get to Desmos. All right, so here we go. Let's see. All right, so I'm going to type those in. So y equals -2x plus 6. All right, and that looks exactly like the one in the picture, so I'm good with that. And then y equals 1/2, oops, there we go, x minus 3. And there we go. That looks exactly like the picture on the review, so I'm feeling pretty comfortable with that. And then, of course, Desmos, I'm looking for that intersection point, right? And there's my lovely numbers, right? So 3.6 and -1.2. All right, so I'm going to go back and then go ahead and write my solution, 3.6, -1.2. And you always want to write your solutions as ordered pairs. I did not do that up here though, because technically we don't know which one is like X, Y, because their variables are, you know, not X and Y. I know this one was X and Y, but that was just because of how I put that in the problem. So anyway, I didn't do that up here because they were word problems, right? But if you actually are graphing them and you're looking for that point of intersection, then we want to write our answers as ordered pairs. All right, there you go, graphing method. All right, the next one says, given the tables, create and solve the system using substitution or elimination. All right, so the first thing I look for is if I'm given a table, I definitely want to see if they actually have any points in common, because if they do, then that is the solution. But unfortunately, in this case, that's not happening. Okay, so you have two choices here. You can always use Desmos because these are tables, right? And as we've learned, right, Desmos will take tables. If you run a linear regression, right, which you're more than welcome to, you can type in the y1 squiggly mx plus 1 plus b. So you can always run a linear regression and it will tell you the equation for you, or you can just do the work yourself, right? And that's totally up to you. I'm going to do the work myself, but if you want to put it into Desmos, that's great. So the first thing I want to notice is that this is the y-intercept, right? Because the definition of the y-intercept is what is the value of y when x is 0, right? So that's the b, and your y equals mx plus b, right? This one gives it to me also. Yay! That's super handy, right? And that was done on purpose, right? So they gave you the y-intercept, okay? All right, so now I just have to find the slope. Well, remember, slope is just change in y over change in x. So I can just kind of go over here, right? Remember how we did this with tables? Like, how are our y's changing? Well, I know to get from -4 to -1, we added 3. And then to get from -2 to 0, we added 2. So if we do change in y over change in x, that gives us a slope of 3/2. So his equation is y equals 3/2 x, and then of course minus 1, because that's the y-intercept that's given in the table. Then we can do the exact same thing on the other table, right? We can find the slope by finding the change in y. Now this one is, we subtracted 2, because we're going from 5 to 3. And then on this side, we're going from -4 to 0, so we added 4. So -2 over +4, which would reduce to -1/2. Or you can put -2 over 4, it doesn't matter. And then of course plus 3, because that's the y-intercept there that they gave us in the table. Again, if any of that makes you uncomfortable, or if you're not confident in your skills there, finding slope in the table, then I'm just going to scooch that over a little bit. Then you are more than welcome to put that table into Desmos and run a linear regression. And Desmos will tell you, oh my goodness. Oh my gosh, never mind. Sorry, I was trying to clean that up a little bit. Desmos will give you those two linear equations. Okay. Now I know it says substitution or elimination, but again, if you're in y equals mx plus b form, there's absolutely no reason why you should do substitution or elimination. So I'm going to cross that out and I'm going to do the graphing method, right? We've already practiced the other two enough. All right, so I'm going to go, sorry, let me write those down for a second because I'm going to forget them. Okay, so I'm going to go back to Desmos. That's not Desmos. There we go. I'm going to go in there. All right, I'm going to type in my two equations. So y equals 3/2 x minus 1. Okay, and then I'm going to type in my second equation, y equals -1/2 x plus 3. All right, I'm going to see where those are intersecting, and that looks like 2, 2. Yep. So I know that my solution, when I go back here, is 2, 2. All right, moving along. All right, so on these, we're going to practice graphing. This is the last page I'm going to do on this video. So we're going to graph some linear equation systems and also inequality systems, because you can see some of these are greater thans and less thans. All right, so obviously in order to graph, you have to put it in y equals mx plus b form. Right, and so that's what we're going to do first. So we have a little work to do because neither one of these are in y equals mx plus b form. So we're trying to get this y all by itself, right? So the first thing we need to do is subtract the 4 over. All right, so we got to bring the 4 over. It's positive on the right side, so it's going to become negative when we subtract it over. And then, of course, our last step is to divide everybody by -2. And remember, every term has to get divided by -2. And also remember there's an understood 1 in front of that x, right? All right, so let's see. These cancel, of course. So that's going to give us our y equals, which is exactly what we're looking for. And that's going to give us -1/2 x, and then negative divided by negative, so +2. So there's our first line that we're going to graph. All right, so let's go ahead and do that. Again, if you don't like the y on the right, you can, of course, switch it around. So let's see, we're a y-intercept of +2, and then our slope is -1/2, which means down 1, right 2, down 1, right 2. And you want to keep that going all the way through and get a very accurate line, because remember, we're looking for where these lines cross, and if your line isn't accurate, then you will have a hard time telling where it's crossing, right? All right, so there's that guy. All right, now I'm going to do the other one. He's in standard form, so I need to get this y by itself, which means we need to take the 2x term, the whole term, and we're going to move it over here by subtracting 2x. I'm going to put that subtracted 2x in the front because I like my mx plus b. I like my x term first. If you want to write it in the back, you're more than welcome to do that. And then we want to divide everybody by 4. And of course, these cancel, or they give us 1y, which is exactly what we're looking for. And this is going to reduce to -1/2. Oh goodness, I see what's happening. And then of course, -4 divided by 4 is -1. All right, so hopefully we can all see what's going on here, right? So this guy has a y-intercept of -1, but he also has a slope of -1/2. So do you remember what that means? All right, because the solution of a system is the point that the two lines have in common, which is where they intersect. But clearly, these are parallel lines because they have the same slope. So these lines will never, ever cross. Right, so the answer to this guy is no solution. If the lines never cross, then they never have a point in common. Right? And again, I knew that going in because after I put these in y equals mx plus b form, I could see that they have the same slope, right? And same slope means parallel lines. I'll write that little note here. Same slope equals parallel lines. All right, let's go graph some inequalities. Here we go. Luckily for us, these are both already in y equals mx plus b form. So we just have to worry about whether it's dotted or dashed or solid line, and whether we shade above or below, right? And so once it's in, and it has to be in y equals mx plus b form first, right? So this guy's ready to go. So notice it has the equal to bar, which means solid line, not dashed or dotted, because we can actually equal. That's because of this guy right here, right? So if we can equal everything on the line, we want to make it a solid line. And then the greater than symbol, we want all the y values that are greater than the line, which means we're going to shade above the line where all the y values are bigger. Okay, so that little symbol tells us two things. All right, so let's graph our lines. So the y-intercept is -3. The slope is -2. That negative is kind of hiding over there. So that means we go down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to keep that going here. Up 2 over 1, up 2. There we go, there we go. And it is a solid line. So I'm going to draw my solid line. And we want to shade everywhere our y values are greater. So I look at my y-axis. So that's everything above the line. All right, so I'm going to get a little highlighter here. So I'm going to shade all of this. So every single point to infinity, right, that exists on this side of the line would work when we plug it into that equation, right? It would make it a true statement. All right, let's go do the other guy now. So y is less than, okay, so that sign speaks volumes because it tells us two things. It does not equal to, so this is a dotted or dashed line. And it's a less than symbol, which means we will shade below because we want the y values that are less than the line. Okay, so we got to graph the line. So we start at +4. Our slope is also -2. What do you know? We just talked about parallel lines. But that has a different connotation, though, for shaded regions. You got to be careful. You don't really know what your solutions are until you graph it. There we go. And we want everything below the line where our y values are less than, right? Remember, you're looking for that y-axis. So we're going to be shading all of this. This is our shaded region for that line. And then our solutions are the region where they overlap, right? And it's up to you to kind of see that right here. That's not dark enough. Let me go gray here, right? So this right here, this is where my pink and purple solution regions overlap. So those are the solutions that these two inequalities have in common. Okay, so I'm going to put a little dot, I'm going to put a little arrow here, solution region. And you may or may not, oh, it does ask you down below, sorry, I didn't even see that. So solution region. So then you'll be asked to find a solution and then a non-solution. So clearly a solution is any point that exists anywhere in that solution region. I'm just going to pick 0, 0 because it's right there. So 0, 0 would be a solution. And then a non-solution would be anything that's not in that shaded, double shaded region. So I'll just pick like this point. You can pick any point, that doesn't matter. So I'm just going to pick 6, 2. Okay. All right. Oh, I didn't even notice. There we go. The solution. I didn't notice that was down there. So solution is no solution. There we go. All right. Number 8 and 9, we're basically doing the same thing. So number 8 is also an inequality, but he's not in y = mx + b form. So we definitely need to do that. So we need to solve for y. So I need to bring the x over. So I'm going to subtract the x because he's positive on the left, which means he has to be negative on the right side. And then I'm going to divide everybody by +2. Please don't forget there's an understood 1 right there. Okay, so the 2's are going to cancel or reduce down to 1y, which is exactly what I want. And then I got a less than -1/2 x + 3. All right, so there's the inequality that we're going to be graphing. Right, I'm going to kind of do the same thing we did a second ago, right? I'm going to kind of analyze my symbol first, right? It's a less than, which means it's a dotted or dashed line. And it's a less than, which means we're going to shade below. Okay, all right, let's graph it. There we go. So +3 and a slope of -1/2. Okay, and then I'm going to dot it, and I just realized I didn't dot the other graph. As soon as I started dashing this one, I just realized that. I'll go fix it in a second. All right, so dotted, and then we're going to shade below the line. Okay, so there's all my solutions for that guy. Oh my goodness, I can't believe I did that up here. My pink line should be dotted. Let me fix it because we don't want that to be the case. There we go. Sorry, you guys are probably watching the video and like, why aren't you dashing the line, Miss Chester? There we go. Oh, okay. Sorry about that, y'all. All right, coming back up here, let's see, I'll pick this green color. We need to solve for y, so again, we need to subtract the x to the other side, so negative 2y is less than or equal to negative x minus 2. And then we have to divide everybody by negative 2. Now this is when little bells should be going off, right? Because you're like, oh, I'm dividing by a negative. And that's really important when you're dealing with inequalities, because that means we need to switch or flip the inequality symbol so that we keep that truth value the same. So it was a less than or equal to, but it has to flip and become a greater than or equal to. And then this is a positive 1/2 x because it's a negative 1 divided by negative 2. I don't know what our thing is with positive or 1/2 on this review. And then plus 1. So there's our inequality. So important that you flip the symbol. Put a little flip symbol. A little reminder there for us. All right, that's because we're dividing by the negative. All right, and then also I just want to do a little quick recap, right? Because that symbol, now it's a greater than or equal to, which means it's a solid line. And then greater than means we're shading above. So solid line, shade above. All right, so let's see. Our y-intercept is positive 1. And then we're going up 1 over 2. So they definitely intersect. Up 1 over 2. Or down 1, left 2. And this is a solid line. I'm going to make sure I pay attention to that this time. There we go. And then it is a greater than, so we're shading everything above. So for this line, these are where all his solutions lie. And you can clearly see after we've graphed it, right, that our overlapping solution region, right, is over here. I'm just going to kind of scribble that in a little bit, right? So this is our solution region. We go. So when they ask us for a solution and a non-solution, right, I just need to pick some point. It does not matter which one. Well, I'll just pick, I'll just do negative 6,2. Just jumped out at me. So negative 6,2 would be a solution. And then a non-solution could be anywhere else other than that graph. It can be in the green, it can be in the blue, it can be in the white. It doesn't matter. I happen to notice here that the origin is not in the double shaded region, so I'll just use him. Okay. All right, and then our last question is another equation, right? These are linear equations, not inequalities anymore. So we are just going to graph this guy, putting him in y equals mx plus b. So here we go. We're going to subtract the x to the other side. Don't forget that that's still a negative y. So the x becomes negative because we subtracted it over. And then we need to divide everybody by negative 1 because there's an understood negative 1 in front of that y. So those cancel. So let's see, what does that give us? A negative divided by a negative is going to give us a positive 1x. And then a positive 1 divided by negative 1 is negative 1. All right, so let's graph that guy. So y equals x minus 1. Okay, so minus 1. And then, of course, remember, our slope is 1 or 1 over 1. So we're going to go up 1 over 1. And it's an equation, so I don't have to worry about dashes or anything, right? Totally a solid line. And there it is, no shading, right? Because this is an equation, not an inequality. So there's that guy. All right, then I'm gonna go to our other one. So let's see, the y is almost by itself. It looks like we just need to move the 1 over to the other side by subtracting it. So we're gonna end up getting x minus 1 equals y. Oh my goodness, that's the exact same equation we just had, right? If I graph another x minus 1, right, then we're gonna have I'm gonna be graphing that exact same line on top of the other one I just did. So hopefully you guys remember what that means, right? These are called coinciding lines, right? Because they're happening at the exact same time and spot. And so that means our solution is infinite. Because the solution is the point that the lines have in common, and these lines have every point in common for all time, for all infinity. All right, I'm going to stop there because that's where our Unit 5 stops for systems, and then we'll pick back up on number 10.